Okay, now let's move on to logarithmic laws. These laws are only going to be applied when the bases are the same, okay? Now, before I start with these, I just want to give you a quick reminder of the exponential laws, right? We were able to add our exponents, add our powers when, for example, we had multiplication between our results, okay? So when 2 to the power of 3 was multiplied by 2 to the power of 2, we got 2 to the power of 5. Right. We also had the division rule, which stated that when 2, for example, to the power of 3 was divided by 2 to the power of 2, if they were the same bases, then the powers will be subtracted during division, and so that leaves me 2 to the power of 1, because 3 minus 2 is 1. Right, so there's addition between powers when there's multiplication between results, subtraction between powers when there is division between results, and when a, let's say, base was raised to a power and then this whole thing was raised to another power, we are going to be multiplying the powers to give me 2 to the power of 12. These are your rules of exponents. We understand that logs and exponents are two sides of the same coin, and thus we are going to be finding these rules just looking at them from different perspectives within logs. Remember that when you are talking about logs, you're talking about inverse functions. The result is not y, it's x. And we understand that x is the power. So let's say we're going to have 2 to become, let's say, 4 plus log of 2 to become 8 is equal to, so in this case over here you can see that okay, sorry, I skipped ahead in order to example. But anyway, as I mentioned, the logs over here are supposed to be your x, because x is supposed to be log of a to become y, and x also happens to be the power. I usually denote it as a to the power x equals to y. Therefore, x happens to be the power, and x can also be written as log of a to become y. Therefore, this entire log over here is the power. And notice that when there's addition of logs, there's addition of powers. That means there's multiplication of our results. Okay, there's multiplication of our results. This is 2 to the power of 2, this is 2 to the power of 3. These are your results, okay? And so when there's addition of this entire thing of logs, there is multiplication of results. In other words, we're going to have log of 2 of 4 times 8. Okay, so this is the first rule. It's known as the multiplication rule. That means it's basically when there's addition of logs, which I also like to call powers, since the result is x, the output is x, which happens to be the power in the exponential one. When there's addition of powers, there's usually a multiplication of results in exponents, which is a rule that we took a very long time ago and we're very familiar with, and we're just now stating it in a different way. There's nothing different, okay? Now, in the case of, let's say this example over here, log of 5, and it became 5, plus log of 5 to reach 125. Again, they're the same base, and so we're able to apply the rule of multiplication. There's addition, so again, the rule of multiplication, and so it becomes log of 5 to become 5 times 125, which I believe is 625. So what's it called? You get 625. And this, again, is the multiplication rule. I'm going to write it down in terms of x and a, okay? Log of, let's say, y, let's just write it down in terms of variables. So, for example, log of n to become a plus log of n to become k is equal to log of base n to become a times k. This is the multiplication rule. Now, for the division rule, it's also the same thing. Notice that when there is division between your two results, there is subtraction between your powers. And so when there's subtraction between the powers, there's division between the results. A power is also known as logarithms. Therefore, when there's subtraction between logarithms, there is division of our results. So log of 2 to become 8 minus log of 2 to become 4 is the same as, or let's make it, so that log of 4 is going to be the same as log of base 2 of 8 divided by 4, which we can then simplify even further and write it as log of 2 to become 2, which has a solution of 1. Okay, so this is the division rule. I'm going to give another example for a division rule. Let's see. For example, log of 2 to become 128 minus log of 2 base 2. I understand that I'm using 2 quite frequently, didn't really mean it, but the example still holds for every other number, of course. Okay, log of 2, and there is subtraction, there must be division between your, results. 128 divided by 8 is also 16. Okay, one final law, which actually is derived from the previous one. So I'm going to give you an example, and I want you to work it out on by your own. So let's see. Log of a to become p plus log of a to become p is, well, I guess because we have the multiplication law, we can say this is the same as, log of a of p times p, which we know that p pi times p can be written as log of a to become p squared. Interesting. But we understand that there's actually 2 of the same thing, so we can write it as 2 multiplied by log of a to become p, and that's the same as log of a p all of it squared. Cool, okay. Now, what if I had another log a to become p? Wouldn't that give me 3 lots of this thing? And wouldn't that mean a multiplication of p times p times p, or p to the power of 3? And therefore that gives me that 3 lots of this thing is the same as log of a to become p cubed, which is really cool and also weird. If I added another log of a to become p, you're also going to get 4 p's, and therefore you're going to have this much and 4 lots of that. And here we come to the newest log law, which is actually the power coefficient law. Okay, let's say that you have n as the coefficient of log y, or let's say k to become a. That's the same as log of k to become a to that power, to the nth power. And this is just essentially coming from the multiplication rule, and it's way too cool. Anyway, I hope this video was useful. Thank you guys for watching.